Hi, in this video I'll show you how to make this single cam shuffling mechanism. Before I show you how to make it, I'll show you roughly how it works. As you can see, there are three components: the cam in red, the follower in blue, and the pin in green. The cam is it's this circle here that converts the rotational motion of the motor, or what you're using to drive it with. It converts that into a walking motion. The pin here in blue, that's what the follower rides on, as basically it just acts as a guide rail, and you can see how it follows it throughout the entire 360 degrees. And the third component is the follower. This basically it's the component that links the pin, the cam, and the ground all together to create the motion. And another important part about this follower is the foot geometry below. It has a very specific geometry that allows it to very smoothly walk across the floor, so you can see how it just glides across the floor, and I'll show you how to design that later. But yeah, this is the basic design. So I'm starting out with this brushed motor. It's by Repeat Robotics, and it's for an ant weight. And I'll create a new component. And the first one I'll name it cam. And I'll create a construction plane to create my first sketch on. I'll project off of this, but I'll actually line it up with this face because that's where the D shaft starts. And that'll be good. And I'll create a sketch. And looking at the profile of this D shaft, I know that this circle here is 4 millimeters in diameter. I'm gonna add a slight tolerance, so it's a snug fit instead of being too tight. Now the second dimension I will add a line across the top here to interface with the D shaft, so it actually can drive it instead of sliding. Oh wait, and the next thing is the actual outside circle, and I'll just put this circle random dimension. The only thing that matters so far is that it's directly above the shaft, so you could add a constraint to hold that there, but all I have to do is just I'll set this dimension. Actually, first I'll actually set the dimension between, set this dimension in between the shaft and the circle I just created. Whatever distance this is going to be, that's going to be basically your stride length, and however long your stride length is means how much of a step does your robot take per rotation. And for an ant weight, I'm going to stick with 4 millimeters. I'm going to set this dimension. I'll just set it to 20 millimeters. And that's actually, it completes our cam. And so I'll just extrude it. And I'm gonna extrude it 4 millimeters. however wide you extrude it, that's going to determine the width of each foot. So 4 millimeters works for me. Now the next thing I'm going to do is actually go back into all components and create the next component. And this one will be named pin. And I'll create a sketch. This time I'll just do it on the XZ plane. And I'll create a circle, just putting it randomly. Again, it is it's directly above the shaft and the cam that we just made. First, I'll set its dimension, and whatever diameter screws or pins you have that you could use for this application, that's what you'd set this dimension to. Since I have 4 millimeter steel pins, I'll set this to 4. And I will set this dimension from the shaft to the circle we just made. I'll just set it to 18. Actually, 18. 19. Okay. And that's it for our pin. Now we will extrude it. I'll extrude to some random distance. We can edit that later. Now the next component I will make is the follower. So I'll go back again. And I will create a new component. Now I will sketch on this cam plane, so just the back of this cam. And for now I will hide the brush motor to make it visually easier. Now I'll create another circle. This will be the hole that is rubbing up against the cam, and I'll just give this a slight tolerance, so 20.4 is fine. Now the second thing I'll do is I will create a slot. This is the slot that interfaces with the pin. Center slot. I'll start from here, and I'll just go up a random distance, and I'll actually set this dimension to 4, and then add a little bit of tolerance for 3D printing. And I will set this dimension. This dimension is important. It'll actually be whatever distance the stride length of your cam is multiplied by 2. So in my case this is 4 millimeters. I'll just set this to 8 millimeters then. And the third thing we're going to do is create this rectangle. Thank you. And these distances are fairly arbitrary. I just wanted it to enclose all of the sketches, all of the sketch dimensions we've just made. So I'll just set this to 60 for now, and this to 30. And so we could be done with this for now, but just to make it look cleaner, I'll edit these dimensions to kind of round it off and remove material, since a lot of this is unnecessary. So that's fine. I'll finish the sketch, and Now what we want to do is we want to extrude the positive body. And you'll notice this isn't a curved face yet, and we can't actually change that until we have a rotating model with joints and everything. So first I'll just extrude this. Again, it'll be the same width as the cam. And this is the basic body. And the last component I will make is the housing for the cam shuffling mechanism. And this one is pretty basic, and we can edit it later. Yeah. And now the dimensions for this are somewhat important. First, I'm just creating a rectangle to base this off of, and I will set this symmetry. Wait, I'll set this dimension. Actually, this dimension is already good. Basically, all I was paying attention to here for this dimension is I wanted the distance right here. I basically just want to give it enough room to move, but not too much room where it's going to waste space. So 5 millimeters is fine for now. But once we get this moving with joints, you can actually see how much room it's actually taking up, so you can fill that in and optimize it. So right now 40 is good for that dimension, but for this one I want to make sure that it is the width of our leg times the amount of legs we want to have. And so the amount of legs you have, it basically varies how smooth the mechanism is, but you're trading that off for there's more parts, so it makes it more complex and more likely to break. But for here, I know that I have a 4 millimeter wide follower, and I want 4 legs, so that's going to be 16 for now. And so this for me is complete. Oh, I forgot. Actually, a more important part is offsetting this rectangle so it can actually make the solid body. But yeah, for now, it's simple, but it'll be complete for now. And I'll extrude this symmetrically. And I just want to extrude this past the pin so it can actually hold onto it basically. 25 is fine. And the last edits I'll make for this housing are the screw holes for the motor and the holes for the shaft and the pin. And so I'll just go in and do that now. Now I'm adding the holes for the screws. And for this, I'll be doing two things with this profile. I'll be extruding the counter bore for the screws so that it sits flush with the mechanism so there's no interference. And the second thing I'll do is I'll extrude all the way through this side of the body just so that we can actually access the screws with an Allen key when we need to assemble and disassemble it. So I'll do that now. And I'll actually make this two sides so we can do what I was just talking about. Oh, no. Okay. And so we have that. But once the mechanism is actually assembled, you actually won't be able to open up, you won't be able to access these. So basically we need to, I'll escape out of that, and I'll create a plane. And I want it to go, actually I'll create a mid plane. Mid plane. Thank you. In between these two, and using this I'll split the body. And basically, all you have to do now is insert some screw holes so that when we need to take these two shells apart, we can do that. And so I will just create some screw holes. Yeah. Great. Okay. So now that we have this housing done for now, we can actually go back into all components, and I'll open these back up. And now what we're actually going to do is we're going to create the joints. And for this I'll be using all as-built joints since all of the components are already in the correct orientation that I want them in. And the first one I'll do is between the housing and the cam. And the revolute joint will be around this axis. And actually, basically when you do these as-built joints, sometimes you'll have the wrong component spinning. And so I actually want the cam spinning, not the housing. So if you go back into cancel, all it means is that I did it in the wrong, I selected them in the wrong orientation. So you're supposed to choose the one you want, moving. You want to select that one first, and then you want the stationary component, and then you select that one. and this will be a revolute, of course. And so now you can see that this cam is spinning and not the housing. I'll create another as-built joint on the follower and then the cam. It'll be on this circle, the outer edge of the cam. The third joint I want to make is between the pin and the housing. And you won't actually see the pin moving. It's very faint, but the pin is supposed to be moving. This is it basically just helps us create the animation, but in real life this won't actually be spinning. It'll stay in place while the only the cam and the follower are actually moving. And so that is good. And the last joint I'll make is actually between the follower and the pin, and this will be the only revolute, or sorry, the only slider joint in this tutorial. And that slides up and down. That looks good. And if you go into the joints up here on the left, you can go to revolute 1 is what I want, and I'll hit animate joint relationships. And so this is what it should look like. The only problem with this is I just noticed that basically when it's spinning, both the follower and the housing are intersecting. And what you can actually do is, one, you can either widen the housing, or two, you can cut off parts of the follower. And for this, I'll actually be cutting off parts of the follower just because it's easy. And basically, this just helps. It just helps keep everything compact and as space efficient as possible. So I'll hit escape, and then I will actually right click this and go to drive joints, and I'll take this, and basically as soon as it stops moving laterally, I will pause it there. So you can see in this motion it's moving across, and then it stops, and then it starts to move down. Right as it stops, that's what I want to leave it at. And for me, this is good. I will edit the follower. I will create a sketch, and we want to capture the position that we just made. And I'll project the housing. I'll project this inner wall, and I'll turn this projection link off so we can extend it. And then I will just offset this by, that's not right. First I'll offset this by, let's turn that off. It's very finicky. Okay. I'll just offset this by -0.2. This will just give me a little tolerance, a little bit of room for error. And so now this is the only line we really care about. Now I will create a line to mirror it off of, so a center line. So I'll just drag this across, and I will mirror this center line. And since I made this a center line, Fusion already automatically knows that this is the one I want to mirror it off of. So it's just a nice convenience. So this is done. Now I can extrude this. Oh, no. I can extrude this through, but for some reason Fusion always intersects. It always edits other components too. I'm still needing to figure that out. If you know why, please leave a comment down below. But I will go back. And so now if you go into all components and you animate the joint relationships, you can see that from a side profile it doesn't actually intersect. There's a little bit of a gap, and that's exactly what we want. And so now that part is done, but you still might notice that this actually isn't, it's not a curved geometry yet, so that's what we need to do next. We actually need to create the ground component first. So this, all it means is this is the floor that the robot will be walking on, and this body will just reference to. And so now I will create a new component, and I will label it ground. Okay, and to find where the ground will be, I actually need to drive this joint, and I will set it to 180 degrees because this is where the leg is fully extended. It can't go any further. And I will create this sketch on this plane. And now I'll just create this rectangle. Doesn't matter what size it is, really, just big enough. And the only thing that matters here is that the leg of the mechanism and the ground, the top of the ground, if they are collinear, then that's how we want it. And so this is good. I'll just finish the sketch, and I'll extrude this out just far enough. And so now here's where we edit the follower. And so with the follower, we actually want to drive this joint until it stops moving across and starts moving up. So I will look at that here. So basically for me, I think it stops at about 210 degrees, and then it picks up the foot. And so that's what I'll pause it on, but it might be different for you. And I will create this sketch on here. And I'm going to project this line, and I'm making sure that the projection link is off so we can edit it however we want. And now I'll create a line to mirror this projection line across. So center line. And what we actually want to do is I'm just going to right click this and make it a center line, or no, rather a construction line. And so this line is what we're going to mirror this line across this center line. So I'll do that. And the last thing I actually want to do is I need to fix these in place so they can't move at all. And for some reason Fusion 360 doesn't like it when there's a symmetry constraint and a lock constraint, so right now I'll just go ahead and delete those. So those are gone. Now the last thing we want to do is take this circle, it's just a random circle, and I will tangent to this line. I will tangent it to the other line, and then the last line I'll tangent it to is the foot of the shuffler. And so now when you're done, this circle will be usually very large, but it should look something like this. And it's a very slight curve. And so now we will extrude this. So it just cuts off this little bit. Fusion 360 has been acting very laggy today. I'm not sure why. Okay, there. And I just want to turn off the ground so it doesn't cut into other components. And so here is the basic mechanism pretty much complete. If I go into all components, and for now I'll hide the housing so we can see the internals. And you play this animation, you can see how it basically just glides across the floor. And you can tweak this however you like. That's pretty much it. This is the basic mechanism. This is not a complete thing that you would just print out or have it manufactured. Basically, there's a lot of places where you need to hollow out material, or you would need to just optimize it for strength. But here is the basic mechanism, and this works for me. Thank you. Goodbye.